Welcome back to my channel. My name is Prachi Sharma and today is the last day of the test series. That is, we are working on chapter 12, Organic Chemistry. So this entire series has been so successful and I am getting a good response from all the students. So we have decided to go forward and start a series for sample papers. So make sure that you stay tuned, subscribe and stay connected and see what the channel can bring more for you. So without wasting any more time, let's get started with organic chemistry. So students, I hope my screen is clearly visible to you. So this test paper was released yesterday on the Telegram channel. So I hope you got a chance to try the test paper on your own. So without wasting any time, we'll start with the first question. So the first question is match the following. First, I'll help you mark the ones which are not in the syllabus this year. The syllabus has been cut down a lot. So in a lot of questions, there would be parts and you can say sub parts which are not in your syllabus this year. So I'll start with the first one. So in the first one, your dehydration of ethanol is not there. Let me mark that. Oxidation of ethanol is not there. You only have hydrolysis of ethyl bromide and hydrogenation of ethene. So if you think about it, what is hydrogenation of ethene? So that means you're adding hydrogen to that. So if you're, so these two are in the syllabus and these three are not. So if you think about hydrolysis of ethyl bromide, so your answer should be ethanol. Okay, because you're adding, hydrolysis means adding water. Then hydrogenation of ethene, you're gonna get ethane. Hydrogenation means you're adding hydrogen to it. And ethene is a double bond carbon. So carbon-carbon double bonds. You end up adding hydrogen to it. So you're adding extra hydrogen. So this bond would break. You'll get single bond and you'll satisfy all the valencies with H's. So you end up getting ethane. That is a single bonded hydrocarbon. Moving on to the next one. In this one, 7th is not there. And I think that's it. That's all about it. Let's start with the first one. So first one is CH4 plus oxygen gives you in the free supply. So free supply of what? Free supply of oxygen. What would happen? So hydrocarbons are very good fuels. Why is that? That is because when you burn them or when combustion happens, you get a good amount of heat supply, energy supply. Along with that, you get carbon dioxide plus water. So in this case, you will get carbon dioxide plus water. You don't have to mention heat if they have not given you an extra column for that. Then C2H6 plus oxygen in free supply, you'll again get carbon dioxide plus water. And C2H2 plus oxygen free supply, you'll again get carbon dioxide plus water. The difference in these three equations would be of the balancing. So you have to make sure that you spend some time on it and balance the equations on your own. If you're not able to do it, I will be happy to help you out. Now, let's move on to C2H5Br plus KOH. What will that give you? So this K will combine with Br. So we end up getting KBr. Okay. Along with that, you have OH. That combines with one of the H's here. You get H2O. Now what are you left with? You are left with C2. So you have C2H. Yeah, I'm seeing it correct. Yeah, so you have C2H, so this will become C2H2, that's it. Yeah, you have C2 and H, one H was given, so you are left with C2H2. Let's move on to the next one, CH4Cl2. So when you have CH4, so what happens? The compound would look like this and you are trying to add in chlorine in that. So when you add up chlorine, one hydrogen goes away, combines with one chlorine and gives you HCl. And the other one takes space instead of the hydrogen. So you end up something like this. So if you write this correctly, so this will become CH3Cl. CH3Cl. Now next is calcium carbide. CaC2 plus water. So CaC2 will end up giving you CaOH whole twice plus C2H2. Next is CH3COONA plus NaOH in the presence of CaO. Okay, that is calcium oxide or quicklime. So what would happen? You will end up getting CH4 plus Na2CO3. So I hope this makes sense so far. All of this has been discussed in detail in one of the videos that is on the channel. I will add the link to it in the description box below. So make sure that if you have any doubts about these, you go ahead and check that out and understand from that video before you try out questions any further. So let's move forward to the next part, that is part 9th. So this is part 9th. So you have C2H5COONA plus NaOH. Okay, so what happens is this Na combines with this Na here and you get COO. So you get CO3. So one L. Let me just write it properly. So this part combines with this part. Okay, you can see it now. So COONA combines with NaO. So what do you end up getting? You end up getting Na2CO3. And what is left out? You are left with C2H5 and one hydrogen. So that hydrogen combines with the H here. So you get C2H6. Then in the next part you have CH2Br, and you are adding zinc to it. Okay. So this zinc will combine with the two Brs, and that will give you ZnBr2. And what are you left with? You are left with CH2CH2. You do not have any extra hydrogens. So what will the carbon do? Carbon will make carbon-carbon double bond, and that will look something like this. Carbon-carbon double bond, H2H2. So you will get that. In the next case, you have CH3I and nascent hydrogen. So this nascent hydrogen combines with I and gives you HI. What are you left with? You are left with CH4. And in the next one also same thing happens. H combines with I. You end up getting HI. And you are left with C2H5. That's it. Sorry, C2H6. C2H6. One hydrogen will combine. C2H6. Now, moving on, we have complete the following table. So, they have given you the name of the reagents and they have asked you what will be the change you will observe in ethane, ethene and ethine. So, the details of this is not in the syllabus, but I'm still telling you the answers for this because it is important for you to understand what's happening. So, for the Bayer's reagent, ethane shows no change. I always suggest go one hydrocarbon at a time. For example, if you are talking about ethane, write all the answers of ethane. Then talk about ethene and write all the answers of ethene. So, always go one column at a time. So if I start with ethane, so for Bayer's reagent, ethane shows no change. For Felling's solution, it shows no change. Then same thing will happen for Tollen's reagent and bromine solution in carbon tetrachloride. So it won't show any change in any of these. Now when we move ahead to ethene, so the first one is Bayer's reagent. So ethene will decolorize Bayer's reagent. Okay, so let me write all of that here. So you are getting no change, no change, no change. And in this case, you will get decolorize. Okay. And ethene has no change on Felling's. So no change here. Then no change in Tollen's. And for your bromine solution in carbon tetrachloride, it decolorizes that. Then moving on to ethyne. Okay. So for Bayer's reagent, ethyne decolorizes that. Then with Felling's solution, it gives the red PPT. And ethyne with Tollen's reagent gives white PPT. And for bromine solution in carbon tetrachloride, it decolorizes that again. I would still mark this as it's not a part of the syllabus, but just take a look at this question once. Moving ahead to question number 4, that is IUPAC naming. I do have a video on IUPAC naming only, in which it's about 15 minutes video in which I'm teaching exactly how to name compounds and how to write the formula from the name. So make sure that if you have any doubts, I have taught that from complete basics. So if you have any doubts in IUPAC naming, please make sure that you check that video. Now let's look at this first one. So you have CH3, CH2, CH2. So how many carbons? First of all, select the chain. This is the chain. How many carbons do I have? 1, 2, 3, 4, 5. I have 5 carbons. So my chain would be pent. All of them are single bonds. So that is pentane. Okay, there is nothing else connected in the chain. Now next one is 1, 2, 3. 3 carbons. So 3 carbons will be bromo. All of them are single bonds. So bromane, bromo, propane. So bromo, propane. And on the second carbon you have bromine attached. So 2 bromo propane. Okay, let's move on to the next one. So CH3 CH2. So how many carbons do I have? I have 1 2 3 4. So 4 means bute, and all of them are single bonds. So butane. And on the second carbon you have alcohol connected. So butane 2-ol. On the second carbon you have the OH, that is alcohol connected. Now similarly we'll move on to the next one. So 1 2 3. 3 means propene, ENE. Now the next one is 3 carbon bonds, 3 covalent bonds, and you have 3 carbon atoms. So that would be propyne. Now students, moving to the fifth question. Alkanes are dash hydrocarbons having general formula dash and undergo dash reactions. So alkanes are what kind of hydrocarbons? Alkanes are saturated hydrocarbons. So alkanes are saturated hydrocarbons having general formula CN H2N plus 2, and they undergo substitution reaction. Why do they undergo substitution reaction? Because all of the bonds are single bonds. Okay, all the hydrogens are single bonds. So to add up anything in that compound, you have to substitute the hydrogen. So hydrogen will move out and that particular element or the compound will get added up. For example, chlorine. So H will go and Cl will join in. Okay, so substitution. You remove one and add something else. Whereas when you talk about alkenes and alkynes, they undergo addition reactions because the double bond can break and give you extra spaces for the elements to get added up without removing anything. So they undergo addition reactions. So alkenes are unsaturated hydrocarbons having general formula CnH2n and undergo addition reaction. Now ethanol one is not in the syllabus. The next is the main constituent of vinegar is acetic acid. Now Tollens reagent, now this is not in the syllabus but I will still tell you, that is ammonical silver nitrate solution. So this is ammonical silver nitrate solution. Now the next is dash is branched chain isomer of butane. So branched chain isomer of butane. So what does butane look like? So butane is 1, 2, 3, 4. All single bonds. This is what butane would look like. The chain isomer of butane, what will that look like? It will be 1, 2, 3 and this will be another carbon on the center carbon. So this will be your isomer. How will we name this? This will be 2-methyl because this is meth. 2-methyl propane. So you will just have to write the name of it. You don't have to draw the isomer if you don't want to. So the answer will be 2-methyl propane. Now the next is but1-ene and but2-ene are the examples of what? So they are the examples of position isomers. Because at 1 you have the double bond at the first position, and then 2-ene, that means you have the double bond at the second position. So this is position isomers. Now when we move on to the state whether the following, okay, this true and false, first, second and fourth is not in the syllabus. Let's look at the third one. The major product of dehydrohalogenation of ethyl bromide is ethene. That is true. The catalyst used during hydrogenation of nickel is nickel. That is also true. Nickel is the catalyst that we use. Now let's move on to the next question. So students, I hope so far you have understood everything. There was not a very difficult portion so far. You had basic IUPAC naming, you had fill in the blanks, multiple choice You had fill in the blanks true and false. Okay, very basic questions. Now we are moving on to multiple choice questions. So the first one is, the compound having the same molecular formula but different structural formula are dash. So those are isomers. Okay. In an organic compound, the group that maintains its identity in a chemical reaction. So you are maintaining the identity. Okay. What will maintain the identity of the chemical reaction? So that would be alkyl group. No, your functional group does not. None of these no. Both of these no. Okay. For deriving the formula of the first member of carboxylic acid, the value of N, that is number of carbon atoms, is taken as. I have seen a lot of students getting this answer wrong. Okay. So the answer for this is 0. Now, how do we know that? If you think about methanoic acid, so all the students tell me it is CHCOOH. That is methanoic acid. So we have one carbon here. So that means the answer should be 1. But students, let me explain you this. The general formula for a carboxylic acid is CN H2N plus 1 COOH. Okay. So when you end up taking C as 0, so this becomes C0 H1 COOH. So HCOOH is your methanoic acid with the number of carbon atoms selected in the general formula is 0. Okay students, make sure you remember this one. Now the next is, the fourth one is not in the syllabus. Then the next is alkanes are commonly called as paraffins. Okay, they are commonly called as paraffins. Now let's move on to the 8th question. Methane is the first member of alkane. When it is treated with excess of chlorine in the presence of diffused sunlight, forms carbon tetrachloride. Okay. Draw the appropriate structure formula of carbon tetrachloride and state the type of bond present in it. Very, very simple question. What is carbon tetrachloride? You have one carbon and it is connected with 4 chlorines. This is carbon tetrachloride. And in the next part they are saying state the type of bond present in it, that is covalent bond. And that's it. That is what they are asking. Define isomerism. Okay. Now isomerism definition is given directly in the book. You can pick that up. But if you think about it, it is when you have the same formula name, that's the same formula but different structure of a compound, that is isomers, and the phenomena is known as isomerism. I would anyways write the definition somewhere in the sheet itself, so that when you're downloading this answer script, you have the definition on there to revise. Now next is give the IUPAC name of the isomer C4H10 which has branched chain. Okay, so C4H10 is what? It is butane, and branched chain for that would be what? 1, 2, 3, 1 branch here. Sorry, not CLC. 1 branch here. And we just did the answer for that. So what was the IUPAC name for that? It was right here. That is 2-methyl propane. Okay. So 2-methyl propane. Give the IUPAC name 2-methyl propane. So you can write that down. Is there anything else that we need? Give the IUPAC name and that's it. You can also make the structure for this, because in this question give the IUPAC name and the isomer of the isomer C4H10. Yeah, you can draw the structure also in this one, just to enhance your you can say the value of your answer. So make the structure and also write the name of it. So that is 2-methyl propane. Now addition reaction and substitution reactions are the types of organic reactions. Which type of reaction is shown by ethane? So ethane, as we discussed, ethane has all the valencies satisfied. So they only show substitution reaction. Whereas ethene can show addition reaction. Now next is give reasons for the following. Methane does not undergo addition reactions, but ethene does. The answer is that ethene is an unsaturated hydrocarbon. So it has double bond. So it is easily able to add up another element in it. Whereas when we talk about methane, methane is a saturated hydrocarbon. So it does not show addition because there is no space to add up an element in the compound. Then in this case, in the give reasons also, you can give examples. You can make the compound and give examples. Now the next is ethyne is more reactive than ethane. So why is that? Because ethane is a single bonded covalent bonds, whereas ethyne has triple bonds. So it is very easy to break a bond and add up something in it. Okay, it is easily breakable. The triple bonds can break down and easily show reactions, whereas ethane is a very stable compound because all of the valencies are completely satisfied. Now when we move on to the next one, that is hydrocarbons are excellent fuels because when they are burned, they produce a very large amount of heat energy. Okay, so students, I hope so far you are able to follow through. If you're not, anyways I will write all the answers in the script, and when you're downloading the script, you will be able to take a look at all the answers. And still, if you have any doubts, you can personally reach out to me on the Telegram channel, and I'll be happy to address your doubts and help you understand better. So let's move on to write balanced chemical equations of the following reactions: ethane and oxygen in the presence of molybdenum oxide. Okay, so what the reaction would be, let me find some space, I'll just write it here. So it would be, you have ethane, so C2H6 plus oxygen, that would give you CH3CHO plus water, and this is in the presence of molybdenum oxide. So MO small and then a big O, MOO. Then the next question is preparation of methane. This is done. Preparation of methane from anhydrous sodium ethanoate or sodium acetate. Same thing. So what is the formula for sodium acetate? First of all, write that. So that is CH3COONA, and you're preparing methane, right? So what will you react that with? You'll react that with NaOH and in the presence of quick lime, and that will give you CH4 plus Na2CO3, and that's it. Now the next one is you're heating ethanol at 443 Kelvin. This is not in the syllabus. Now next is draw the structural formula of a compound with 2 carbon atoms in each of the following cases. An alkane with a carbon to carbon single bond. They are talking about alkane. Okay, so this would be carbon to carbon single bond. So you have to draw the complete structure. Also write the name for it. So this is ethane. Next is an alcohol containing 2 carbon atoms. So C, and then you can add an OH here and then satisfy the valencies. So this is ethanol. Next is an unsaturated hydrocarbon with a carbon-carbon triple bond. When we have triple bonds, we are talking about alkynes. Okay, so triple bond. So this would be ethyne, and you'll have 1,1H with both of them. Now the next question. From the box given above, name the compound with OH as the part of its structure. So its OH is what? Alcohol. So the answer will be ethanol. The compound with COOH as a part of their structure. So that's carboxylic acid. So ethanoic acid. Homology of homologous series with general formula CnH2n. So CnH2n is ethene. Now the next question is, write the equation for the lab preparation of the following compounds. So in this one, ethane from sodium propanoate is in the syllabus. Ethene is there, ethyne is there, methanol is not there. Okay, so let's look at these reactions. So the first one is ethane from sodium propanoate. So sodium propanoate, C2H5COONA, and that will react with NaOH in the presence of quick lime and heat, and this will end up giving you, so as I told you, this part will get combined with this part. Okay, so you end up getting what? Let me write it.
you end up getting Na2CO3 plus C2H6. Okay. Now the next is ethene from iodoethane. So that would be C2H5I plus KOH. That will give you C2H4 plus Ki plus water. Okay. So I hope that much makes sense. The third one is ethyne from calcium carbide. So calcium carbide is CaC2 plus water, and that will give you CaOH whole twice plus C2H2. And that's it.
So my ICSE warriors, this was it for today's session. We were able to go through a whole ton of questions in this session today. I do understand a lot of students find organic chemistry a little bit difficult, so please make sure that you let me know that in the comment section, and we can go ahead and practice more questions from this particular chapter. So for anything that you need help with, please make sure to reach out to me. Make sure that you are subscribing to the channel and sharing this with your friends and family members, and help us move forward. Thank you so much. We will catch up soon in the next session. I hope you have a beautiful day.